Hello and a warm welcome to everybody present here today. Thank you for joining us for today's Payatu Webinar on securing IoT products with security compliance standards. I'm your host, Surendra Niman. Before we get started, let me introduce you to Payatu. Payatu is a research-powered boutique cybersecurity consulting firm. We have a decade-long track record with a singular focus on cybersecurity. Payatu's impact is delivered from their three verticals. Number one, community and conferences. Some of you might already know that Payatu runs Asia's most respected cybersecurity conference, NullCon. Payatu also runs hardware.io, a hardware security focused on conference. Number two, products. Payatu has also released two products in private beta trials, Exploity, a firmware analysis framework, and CloudFuzz, and an advanced fuzzing framework. Number three, consulting and training. We primarily focus on offensive security assessments. This slide is an overview of various consulting assessments we execute for our customers across the globe. We have delivered talks and workshops worldwide in some of the top security conferences such as Black Hat, DEF CON, and Consequence. This has been our decade-long impact to contribute to a robust cybersecurity community in India and global. Now, without further ado, let's get started with our webinar. Today's speaker, Yashodhan, is a compliance manager and an IoT security researcher at Payatu. You can read about his wonderful accomplishments on this slide. Yeah. Before I hand over to Yashodhan, a few housekeeping tips. Please be on mute. If you have a question, you can write it in the chat box. We will answer the questions during the few intervals or towards the end of the webinar. A recording will be released later via our LinkedIn page, so make sure you're following Payatu on LinkedIn. Yashodhan, over to you.
Yeah. So thank you, Surendra, and thank you, participant, for joining this webinar. Okay, let me first share the screen and then we'll start discussing on that. I hope it's visible.
Yes, go ahead.
Yeah. Okay. So as looking from the IoT security perspective, there is always a challenge of maintaining a security at different stages of IoT products, right? And eventually, what happened is this is not a situation in any of the countries. This is all globally situation where you need to protect your IoT product from different threats that are coming, like each year or each month or so. And from that perspective, there are certain organizations which include into maintaining some kind of compliance or maintaining some kind of making some kind of standards that will help IoT makers to secure their products. Right? So to start with, so what is today's agenda is about let's understand what is the need of such kind of IoT security compliance or standards or the guidelines. Right? What is the role that such IoT security guideline compliance plays? Then basically in what terms they help your product to be more secure at different stages of the development and the design. Then we'll see what are the different compliance agencies which give different type of standards or guidelines that will fit to your IoT product in terms of security perspective. Now, each of these agencies will have their certain compliance or compliance number or the guidelines, right? We'll see what are those guidelines which are more popular in the industry, and from that we'll select one of them and we'll just give a overview of that, how they're doing it, how the compliance is helping a product to be more secure, how it helps to create a threat model or risk assessment, and what is regulatory aspect of that. And we'll take a simple case study where we'll try to understand how these guidelines will help to make that particular product secure. Okay, so this is the total agenda for today. Now, starting with the necessity of this particular compliance under standards, right? So in the news and everywhere, you keep on learning a different IoT device has been, been attacked last year in 2020, like trillion IoT device has been attacked. There are many news happening, and that is leading into different issues in terms of either it is losing some kind of critical data of the from the product, or it is leaking some consumer information, and also creating a loss to the businesses. Right? Now, to address that thing, there are different standards, right, which are globally accepted, right? So globally accepted standards are really necessary from that perspective. And these standards, different standards have their own viewpoint of designing this particular compliance from a viewpoint of either from the very industry 4.0 perspective, or looking from the consumer electronics perspective, or any kind of IoT products that for that matter. Now, also there is last year there was a law called as a California IoT Security Law. It's SB 327, Senate Bill 327 has been passed last year, which says that any product, any IoT product, the connected devices that we call, right? If you're selling that particular in California, and if I'm not wrong, in complete USA, it has to have some kind of security, right? Some decent amount of security that is mentioned into that particular law. Otherwise, the company will be sued for that, right? So it is a law, basically. So you can see the criticality of the security compliance that you really need for the IoT part. Now, these particular compliance will assist the product to have a complete secure development life cycle. It helps, at every stages from hardware design to deployment part. It helps and assist the product owners that how security should be implemented at each different stages over there. Not only from the development perspective, it also helps looking from the verification perspective, of security verification and assessment perspective. So they also create some kind of checklist so that it helps not only developers, but the security testing perspective that gives a complete understanding of, the black box or a gray box testing, what we call over there. Now, so this helps the complete IoT makers, the IoT manufacturers, the IoT developers, or IoT service providers. So whoever are included in this particular any of the business of IoT will be get benefited from this particular compliances, right? And there are different sections of the compliance where based on the different roles in which the company is dealing with, or the developers are working with, right? They'll be benefited. Now, the reason for that is being IoT, if we say it's a full stack IoT, it starts from the PCB level, the hardware, the sensors, the microcontroller, the radio part, the wireless part, the protocol part, the network part, the web part, mobile application part, cloud part, as well as if you include the AI and machine learning part as well. So if you look from all this perspective, the different standard and the different security regulations have been mentioned, and they are actually necessary to connect. If you say a complete IoT product, you should include all these components into that, and at each levels there are different security measures that you need to look for. So these compliances addresses all these aspects at different stages of the IoT. Now, what is this particular standards or the compliance? What type of role they play when we go for the product, securing the products, right? So first thing is we are addressing the security issues, right? So looking from the technical architecture perspective, so for the IoT part, it addresses the vulnerable parts, starting from the hardware level, from the PCB level, to the interface levels, to the network level. So what are the vulnerable things that can happen where the attacker can attack, and most sensitive data can be, compromised. Your device can be compromised on different levels. So these issues, first they address these issues, and based on these issues, there are certain guidelines for the risk assessment, right? So when we go for risk assessment, the major three things from the security perspective are always a confidentiality, integrity, and availability, what we call as a CIA triad, right? AIC or CIA triad. So these are the major things that these compliance addresses from the risk assessment perspective for the IoT products. Now, coming to next point, it says that it defines like security level class for IoT products or the services. What does that mean over here? Now, assume that there is a Wi-Fi relay switch. Okay. Now, that particular Wi-Fi relay switch has been deployed in, let's say, at a meteorological station where you have a different sensor data from atmosphere. You're reading some air pollution measurement, PM 2.5 data, nitrogen, NO2 data, SO2 data, something like that. And you're pushing that data over cloud through Wi-Fi. Okay. Now, this is one scenario where this Wi-Fi relay switch has been deployed. And there is another situation where the same Wi-Fi relay has been deployed. The other situation will be, let's say, a hospital where you have some critical patients, the heart patients or the neurological disorder patients. Right? Now, comparing these two scenarios, what will happen for the same product is the security level for the meteorological part is very minimal compared to the security level for the hospital part, isn't it? So these basically the security levels are very much important. Like these standards help to define certain kinds of security levels for different applications. For even if you take a same product, it has a different security levels for the different applications though. So there are standards which says class 0 means there is no security at all. Right? Class 1 is you have a very low amount of security. Class 2 is like medium. Class 3 is a little bit high, and class 4 is a critical security where you cannot escape any of the security measures. Right? So these are the different compliance class that has been created for the IoT products, and based on such criteria, you can look, you can evaluate your risk assessment, you can evaluate your threat modeling, and you create your secure architecture. So these are the, at the beneath these security compliance help you to address these particular issues when you develop certain IoT products. Now coming to these security compliance agencies. So there are many security regulatory agencies globally, and you can see this particular chart, we'll see the full form of those in the next slide. Right? But out of that, if you see like ISO, which is like a king of any of the standards, will always be there, and it has a more authority for than any of the standards and mentioned across the global. NIST is something about all the cyber security. Basically, it's all the standards and technology about standard technologies, and eventually it is it has basically all the cyber security what you call cyber security standards in different manner in terms of whether in terms of algorithm, whether in terms of other compliances or the FIPS kind of thing. So even in IoT, there are some sections. So based on their cyber security, other documents that mentioned into by the NIST, they have referred those things into their IoT compliance as well. OAPS is another open standard. IoTSF, GSMA, ITSI, IoT Ecosystem Alliance, and ENISA. These are the typical agencies. Now we'll see their full form, and we'll see what these agencies actually do and how they help creating the product secure. Right? So ISO is International Organization for Standardization. NIST is National Institute of Standards and Technologies. As I discussed, they have a lot of standards for the cybersecurity as well. And when we come to OAPS, right? OAPS, Open Web Application Security Project. So if someone is into security testing or doing the web security or the mobile security, they know these particular standards very well. They are started as a web, then moved into mobile part, then now they are into the IoT part as well. Right? Similarly, there is a IoT Security Foundation, which is one of the famous, and this is a non-profit organization which deals with the complete IoT stack from your hardware level to the cloud and the web part. And for each and everything, they assign some kind of, the compliance class, what I just discussed in a previous slide. And they create different processes from the development perspective, from the business perspective, from the another security perspective, and from that thing they try to help to create the security architecture, threat modeling, and the risk assessment for that. Now coming to GSMA. So of course, today we'll be talking about this particular GSMA. GSM system, as we know, is about global system for mobile communication, and they have the upper hand in the networking segment, but they have also worked in the IoT segment, where they have defined a different, they have addressed the security issues at different stages of the ecosystem of the complete IoT, including the network part, include a cellular network part and other parts over there. Then we also have something called as a ITSI, European Telecommunication Standard Institutes, which also have some of different standards mentioned into different products of the IoT. Then we have ENISA, European Union Agency for Cybersecurity. So they have in other domains of cyber, standards and compliance for other domains of cybersecurity, and some part of the IoT. So last year, I think they have released something from the supply chain as well. Then we have a IOXT Alliance, which deals with the Internet of Service things. So they deal with a different type of consumer products and other IoT products from the assessment perspective, and they have created some standards on that. Right? So now we'll look into what are these different standards from this compliance agency. Even though there are so many different standards from the same agencies, but what we'll address is what are the top thing that the IoT security perspective they have, as well as what are that will help the IoT products currently IoT products in the market to address majority of the security part. So ISO, though it did not initially have any specific security standards for IoT, which is this is coming in 2022. Final version is coming 2022. What I mentioned here is ISO IEC 27030. Which is still under development. Something I think they have already released some part, but still it's purely into development. But eventually, initially what happened is, since from the perspective of different components of the IoT, from the hardware perspective, or from the embedded perspective, or the firmware perspective, or if you are network perspective, they already have some of the standards, and people are using these individual standards in their different products for the securing them. But now they are coming with as a whole IoT standards, IoT security standards. If you look for, there is one standard called the ISO 17825. This is more specific to hardware attacks, what we call as non-invasive attacks, fault injection and the side channel attacks, what we call. This has been released in 2016. So then coming to this NIST, right? So in, I think, February 2021, they have released the final version of this NIST 800213 standard, which is specifically for the IoT. Right? And as I mentioned, it has also referred other cybersecurity standards they have created over a period of time. Now coming to OAPs, there are since it's an open source kind of thing, so there is an open community for this. So each year, generally, at least for the web part as well as mobile part, each year they keep updating. At least web part, I know OAPS web top 10. I think they have been updated 2020, and web mobile is still, I think, 2016 we are referring. OAPS top 10 IoT was developed in 2018, and still that has been into the practice, right? So it gives us top 10 typical attacks on IoT and how to secure on that. Other than that, they have
yes, Yashodhan, we have one question in the chat box.
Just a minute. Just not able to see that. You can see the chat box. What do you think about PSA certified? Any reason why it's not included in compliance agencies? Okay, I'll discuss on that part. Yeah. Okay, so before, can I address these issues later? PSA part, why it is not included, if that is okay?
Yes, yes, fine.
I'll address that part later. Thank you.
Yeah.
Now, coming to this particular standards, okay. So I was discussing about OAPs, right? So IoT Security Verification Standards, ISVS, what we call, is basically has different security assessment standards where it addresses all parts differently. From the PCB level, what are the attacks possible on the PCB? What are attacks possible on different ports of your embedded systems like UART or a ZTAG or SPI? Also, it deals with the radio protocol like Bluetooth and like Wi-Fi kind of thing, as well as some part into the web part, right? So did have security verification standards for these kind of stuff. Right? Similar to IoT security verification standard, OAPs also has something called as the ASVS, Application Security Verification Standards. Now coming to IoT SF, IoT Security Compliance Framework. Over here, what happens is, like, as I said, they're addressing each and everything based on the risk assessment at initial level. So what is the methodology they follow is, first they check what is the security level your product will need, right? So if it is going in, let's say, a defense kind of thing, it needs a different kind of security, or if it is going kind of healthcare kind of thing, you need a different class of security. It has a higher level of security. But as I mentioned, if I'm just taking the data from the meteorological station, so it has a lower kind of security level. So first, that based on those guidelines, first you define what compliance class your product falls. Then you start looking into the other parts from their guidelines, because what they mention in their guidelines is about, okay, if you are into this class 1 category, these are few steps that are mandatory for you. These are few things that you can exclude. If you're from the perspective of the development, from the perspective of the business, from the perspective of the complete operation. So it addresses different issues, these components from the security compliance part. No, eventually, additionally, this IoT SF also have some reference architectures, security reference architectures for healthcare industry or a different type of consumer product industry as well. Now, coming to GSMA, they have this IoT security guidelines for different stacks from the complete IoT ecosystems. So I'll discuss that more detail, because this is the topic that I'm going to go deeper into it. Right? Coming to ITSI part, right? So ITSI has one of the famous standard called ITSI EN 303645. This is again a standard which is for the consumer electronics. They have basically around 13 compliances, and each compliances will have, I think, 3 to 4 sub compliances over there. Based on that, these consumer electronics here refer to as basically the home automation kind of thing, baby monitoring, the toddler monitoring kind of products. Then you have like some kind of USB dongles and those kind of things that generally available in the consumer market. Right? So these things have been addressed into this particular standard. And this ENISA has guidelines for IoT supply chain, which they released last year as well. Right? So looking for this IoT security SF, GSMA, and ITSI, at least all these bottom 4, they keep updating each and every year. Right? So as the new attacks comes and new the countermeasure comes, they keep on updating on their risk assessment part. Now, what are these goals of this security compliance? Is first of all is basically creating awareness about different possibility of security threats. Right? So that will really help one to create a threat modeling. That is one part. Now, as the IoT field is so much diverse into this automotive, healthcare, and consumer, what they're approaching is, so if you observe same standards like over in 2016, and they're maturing each and every year, what they're trying to approach is they're trying to unify some security model for these different industry for automotive and healthcare. Right? So that is what their goal is for, and they're taking such steps across it. Right? And they also make sure that should be secure. Right? This is actually, you can say, this is the primary goal of this particular compliances. Right? Okay. So now we'll start looking into this particular GSMA IoT security guidelines, what they're telling and how they're addressing these particular security aspects of it. Okay. Any questions you have still now? Yeah, thank you. Okay. So, so basically, if you look from the GSMA IoT Security Guidelines perspective, what they have done is they have created certain kind of recommendations, around 85 recommendations, that in terms of the questionnaires and some kind of, based on some priorities, some recommendations are there, and some questionnaires are as well there. What they help is like, they look from all the stages of your development. Either are you in a design phase, are you creating an architecture of your system, whether you're in a development phase or whether you're in a deployment phase. So all these stages, they give certain recommendations that you can follow and try to implement that to make your system secure. Now, the next point is cover network, service, and endpoint ecosystem, right? So what they're doing is they have the complete IoT model that divide into 3 sections that we'll see in the later on. But these are the on a level that network and service and endpoint, they have something as a majority components for their IoT model. And what they do is they address the security challenges looking from the vulnerability perspective at each and every different stages based on the review, and what are different attack models possible, and based on that, what is the risk assessment of your particular product is, right? So these something they address in their particular guidelines. And one more thing what I forgot is, if you look from the compliance I have mentioned initially, right, they basically they refer each and every one continuously. So GSMA will refer IoTSF OAPs, OAPs will refer GSMA IoTSF, right? So this like kind of fractal things that happen each and every year over there. Now coming to this details about this GSMA IoT security guideline. So what they have done is they have created 5 major documents, right? The 5 major documents they have created. And you can see the names of those things. So here you can see something called as a CLP. CLP stands for Connected Living Program. Okay? And based on that, they have created some documents. So CLP 11 deals with what are the typical IoT security guidelines. CLP 12 discuss with something called the IoT Service Ecosystem. 13 discuss with IoT Endpoint Ecosystem. And there is something called as a GSMA IoT Security Assessment Checklist. Right. So this is basically crux of everything, that it holds all the recommendations based on the priority as well as some of the questionnaires that will help to assess your product when you're trying to design or create an architecture from that. As well as they have created some kind of guidelines for the network operators as well. Okay. So these are the major documents that they have created. So these are the documents. Now we'll see what these components are in this particular IoT ecosystems of the GSM. Right? But what are the challenges this particular document focuses on? Right? So here, what we call as a CI tried, confidential, integrity, availability. So they have just twisted these terms in different ways, but at the beneath they're addressing the same CI issues over there. Right? So when you say availability, ensuring the constant connectivity between endpoints and their respective services, what does mean by, take an example of NB-IoT devices. Right? So they have a lower bandwidth, and they ensure that you should have a secure and as well as continuous connected devices to your server, your endpoint devices to your server and services over there. Coming to the identity part, it says that authenticating endpoint services and the customer or end user operating at the endpoint. So here basically what is mean is like the identity in terms of the authentication that you provide, either in terms of some of the crypto tokens that you have, encryption tokens that you have, or the services that encrypted, you should create your own identity of that. Right? Similarly, in terms of it should also get protected from some of the hardware attacks, like a security called the side channel analysis or the fault injection part, where the attacks will change your authenticity of your complete device. Coming to the privacy part, so of course dealing with the confidentiality part, so it maintains that no others perform any kind of MITM attacks or some kind of thing and try to access the confidentiality of your data from your devices. Right? And of course, like security is something where it is showing the integrity of the data, which can be verified, tracked, and monitored. So these are the major aspects that they have the security challenge they address in their risk assessment process. So this is a typical model that they follow. Right? So you have a major three components: IoT service ecosystem, communication network, and endpoint ecosystem. Okay? So what does this mean is like when we say IoT endpoint ecosystem, it is nothing but the devices which has a limited kind of range, a limited kind of power. So you can consider it as a BLE beacons or kind of a Zigbee devices which has working with a low power and these kind of things, and they have some interface on a user level. On the other hand, when we say the IoT service ecosystem, here it means about web, mobile, and the cloud part where you have a certain kind of APIs and other user experience. And of course, in between communication network, the majority, of course, since being a GSMA, their preference is always for the LTE, 4G, 3G, those kind of thing. But otherwise, they also addresses other part of the communication layer as well as the TCP/IP part also. Okay. Now, so based on that, these three modules, right? These three things has been addressed in the GSMA. What will look, since we are not into communication network as a network operator, from the IoT perspective, what we'll be interested more into IoT service ecosystem as well as endpoint ecosystem. So when we say endpoint ecosystem from the GSMA, so again, they have the three sections for that, where we say lightweight endpoint. Here, it means, as I said, like wearables or the non-cellular or proximity beacons, which has low power, low range, or some lower functionalities, right? That fits into your lightweight endpoint systems. Now, coming to the complex endpoints, what they mention over here is there are large home appliances, considering the refrigerator or your washing machine. They consider these as a complex endpoint over here. Coming to ICS SCADA, though there is a IoT security standard for SCADA and ICS, what we call as a IEC 62443, and again they have different sections for that. This GSMA also addresses some kind of SCADA kind of thing on a high level as a complex endpoint. Coming to the connected cars, so there's still like there is a ISO, I think 21434, if I'm not wrong. There's a automotive security standards, which is again into development phase. But GSMA, as I said, the role of this particular compliance is to unifying all different domains into one security aspect. So they're treating these again connected cars having the OBD and the cellular tracking ability into the complex endpoints. So coming to then third part is about the gateway or hub you have. So where you the device discovery and management functionality over, right? So this is what the endpoint ecosystem from the IoT perspective means, right? So so you can have a low level of protocol, you can say non-IP protocols like BLE and those kind of thing in this particular system. Coming to the service ecosystem, as I said, it deals with complete IoT, cloud infrastructure-based solution, web apps, and the database cluster. So this way, they addresses this risk assessment. Okay. So now coming to this recommendation and risk assessment part, this is something important from the GSMA perspective, addressing the security part. Right? What I have mentioned over here is there are 4 recommendations from the GSMA, 4 classes of the recommendations, which needs to be addressed from the security perspective for that particular product. Okay. So though there are more than 85-90 kind of recommendations, which are not possible to put everything over here, right? Later I'll share the link with you where you can refer these kind of recommendations. But here I've just mentioned some critical part of them. So when you go to the critical recommendations, right? So what here critical recommendation means from the GSMA perspective is, so something, each and every IoT product, even if it's a simple IoT product having some sensor and some kind of protocol transmitting on a Wi-Fi, something, right? So they assume that each and every IoT products from the security perspective should have a secure bootloader. It should have basically a proven TRNG. TRNG stands for two random number generator, which is needed for the cryptographic operations. You also need a critical section of memory to be locked, where you have a critical section of code and data part on that, right? You should have a cryptographically signed images. You should have a password management. and you should have a logging and diagnostic. So I have just mentioned few of them, right? So these are something that comes into the critical part. Critical here means any of the IoT product that you're looking for, making it as a secure. Still on a level where you want more what you call as a more security level to add, they have higher recommendations, secure over to air updates. You should have a tamper resistance casing, and you can have some unique endpoint identities and encryption token and something like that, right? So as you again still go to the medium level, you'll see enforcement of OS level security, disable debugging and testing technology. Though if from a personal perspective, I'll prefer this particular disable debugging and testing technology into critical recommendations. So assume that if your UART ports of the device are open, or your Z tags on the SPI, everything is accessible, right? So this becomes actually critical from overall product perspective, but still GSMA addressed this as a medium. And when you go to the low, there's something called as DOS protection, denial of service, and defeating the cold boot attack. Cold boot attack is something like where whenever you are rebooting the device on a certain instant of time, where basically there is a remnants of the data into your RAM. So you're trying to extract that through some kind of side channel attacks, right? So, but if you observe why they have said this critical, high, medium, low is, these are some of the if you go for medium or low kind of attacks, right? There you actually need the protection from such attacks, which costs you a lot for that particular product, right? So that's why they consider it as a low, because everyone cannot afford that particular thing. Right. So now coming to this, based on these recommendations, right? So as I said, they have certain questionnaires based on such kind of recommendations, and you can create your threat model, and you can perform your risk assessment on that. Right? Now, what are the what is this risk assessment thing that this particular GSM is following? Right? It is following two different frameworks. One is something called as from the NIST itself, risk management framework, as well as something called as a CERT Octave, right? Operationally critical threat, asset, and vulnerability evaluation. So these are the standard cybersecurity risk management frameworks, and they have adopted some of the critical steps from such recommendations for the IoT security part. So what are recommendations that they are giving from the evaluating your security perspective are based on this particular thing. Now coming to effective guidelines. Now, so these are the 5 major steps that they address based on, as I discussed about the NIST risk assessment and the Octave framework. And if you follow these particular 5 steps while from the designing to deployment of your IoT product from the security perspective, yes, there is a chance that you have applied security on a very, very good level. So coming to where let's say when we say evaluate the technical model, right? So when you start understanding the security perspective of it, what does that mean is basically it means is like, first of all, you should know what type of components your IoT architecture have over here, right? So it means that what are the components your IoT systems has. If you are not aware of what type of security components itself you have, then it is not possible to create your security model, right? So first pass it, evaluate your own technical model from the hardware, firmware, and other perspective. Second part is review the current product and service security model. Okay. So what happens over here is, what they say over that now you can start looking into their recommendations. You can check, okay, what are the security issues that you are addressing over there, and what is the possibility mitigations from that as well. Over here, what happens is, let's say there is a recommendation of having, they will ask, do you have a secure bootloader? Right? So if the answer is no, right, then they also address what is the that is the risk that you are facing if you don't have the secure bootloader. Similarly, if the recommendation says that do you have the firmware and do you have the security aspect from the perspective of the UART port, have you disabled those things? So if answer is no, there is no possibility that this will, they will address what is the risk that you are going to follow. Okay. Now coming to the third part, when we say review and evaluate recommendations. Okay. So once you understand these are the risk that you have, so you will review your model from that perspective, assess your model that, okay, these are the parts which are missing from my perspective, which I can, which I need to, critically involve, and which I can drop based on some resource requirement, or based on some other criteria, right? So you can review the complete model, your security model, based on that performance. This also adds that, for example, let's say if you're using some kind of a processor which also have some kind of cryptographic operations, or using some kind of cryptographic stack over there, stack over there, and which has some kind of operations that is model. So that also adds that you have service model, the current service model provides that. Right? Now coming to the fourth part of that, the implementation and review part, where it says that if you that how much no, once it says that, like, from the third point, it you are clear that what are things are possible for you, what are things not possible for you. Okay. And now the next thing is like how you want to implement that. And at each implement stage, you're going to have a different risk assessment. You're checking on that perspective. Right? So this is the implementation part. And once you are done with that, you can say, okay, your product is ready to go for that. But still, again, there is an ongoing life cycle. What does that mean over here is that assume that some of the operations, let's say cryptographic operations that you're using, right? And some of the cryptographic algorithms that you're using, over a period of time, they get deprecated. And for that matter, you have to be very aware that which are functionalities getting deprecated, and you have to have a go for the continuous assessment of that. So now we'll take a simple case study where we'll discuss what kind of, based on the steps that we just discussed. Like, of course, GSMA is a very huge thing, and it addresses many other aspects. What I've just point is the overall view, how they are going to execute that. Now coming to the case study, we'll consider some kind of IoT device, so BLE sensor node, something kind of thing, where which has some kind of accelerometer, gyroscope, temperature, humidity, and microphone sensor standard thing. So assume, like, let's say I'm holding some kind of ST microelectronics IoT sensor node in my hand. So what is it has basically all these kind of sensors and as a BLE capability, right? BLE 4.2 capability. Now what happens is next is about that now these they're following this BLE version 4.2, and assume that this is the battery powered device. And this, if you consider this particular thing, this particular device will fall into the category of lightweight endpoint as per the GSMA. Okay, so here as I discussed, lightweight endpoint GSMA, it means that here I have a non-IP, looking from the BLE perspective, I have a non-IP kind of protocol that is working. I have a low power device, as well as, since the battery power is a low power device, low range device, right? So this comes into lightweight endpoint. Now IoT gateway will have a kind of a BLE scanning capability, where let's say I have multiple such devices and I'm scanning these BLE devices and pushing data over a Wi-Fi, right? So this will come into the category of the gateway, as well as it has some kind of endpoint. So it's kind of mixed kind of thing, where as a gateway it is connecting to some kind of service, as well as an endpoint device, it has a BLE and other Wi-Fi and the hardware part which can be addressed over there. Right? So this is a complete scenario that we have. So likewise, we have case study where we have microcontroller which has a BLE capability and sensors, right? And it is communicating through Bluetooth. So now the overall architecture will be the BLE beacons will be communicated to IoT gateway and a BLE scanner. First of all, BLE scanner will scan the cycle, right? And eventually what will happen is based on the scanning, it pushes data over a Wi-Fi or any kind of any Ethernet. That depends again on the device capability. And this can be available either on three kind of things. So you have application server, you have a web server, and a workstation kind of thing. Even you can have a different cloud kind of thing. So these are the complete backend, black flow of your backend services. Now, think of it as an perspective of the risk assessment part, right? So when I say I want to have these 5 steps, which I discussed just before from the GSMA perspective, right, as well as the recommendations perspective. So what I'll try to look from that perspective when I say a BLE beacon kind of thing. So I'll say basically this is a lightweight endpoint device and having a critical recommendations that I should have a secure bootloader. It should support some kind of random true random number generation. It should have some cryptographically signed images, those kind of thing. They're must for me. Even if I go to the Wi-Fi, this gateway of Wi-Fi, this part also support this kind of functionalities. That is one thing. Now, other part into that, when you try to create a risk assessment, right, from this 5 steps. So what I'll do is I understand, okay, this is my architecture where I have a components MCU. I have a BLE beaconing system as a protocol. I have a sensors. I have a battery, right? So based on these components, what are the areas where I can, have the security attacks? So when I say MCU, possibly I can have the UART port open or SWD port open for the debugging purpose, right? From the BLE perspective, I say, okay, what is the range of communication? From the hardware perspective, I can say, okay, I'm using, let's say, a PFI antenna or a MIFI antennas kind of thing, right? So if I'm having a certain kind of radiation pattern from that perspective, and if I that antenna length or some change into some kind of length of the antenna has happened, if that affecting the radiation pattern of my system, how it is going to affect the security perspective of that, right? So that there are things I can look into that part. And if the same device, let's say the same BLE beacon is used in some normal applications for collecting humidity and typical data, I'll consider the class into class 1, where I need a low amount of security, but same beacons kind of thing. If I'm put that into the on the people tracking in the hospital, right? So I need to have more security over there, so I can have a different kind of tamper proofing case and those kind of thing that comes into the picture. Now, these basically, so this is a general what you call the architecture of this case study. Now, what are the other security issues happens from the endpoint perspective as well as the service perspective, right? So we have an endpoint perspective from the hardware, as well as we have a perspective of a service perspective, where you will look into the factor, what are the services that are running at the background on the server over there, right? So when I say what are the possible attacks that can happen, right? So first pass is about the cloning part, right? So if my endpoint device is able to get cloned, that can be first attack, right? So that is one of the security threat I have. Then if someone is impersonating the endpoint as myself, another security aspect. If the services, like if I have a Bluetooth communication, that here I am considering as a service. So there's something I consider that part, that is again a critical service impersonation, and ensuring privacy. And ensuring the privacy part. What I'll say is about the private data. Let's say if I'm getting some critical data, I'm sending from my device and from my Bluetooth to my server. So what is the confidentiality and privacy into that, right? So these are the issues from the endpoint perspective. When I consider from the security perspective, from the service, again, I can address the cloning part, the hacked services, the APIs and those kind of thing. Also, identifying anomalous endpoint behavior. So for example, if my endpoint has been compromised, right? What is the way the service get acknowledgement that it has been compromised, or can I have such kind of services, right? Now coming to the data exploitation part, if my data is getting exploited from the service part, as well as my privacy or the availability of the service has been get disturbed from that perspective, right? So these are the security models these are the threats I can consider on a high level, right? Now coming to the solution from this risk assessment perspective, what we discussed, right? So reviewing all these recommendations that from the secure bootloader or the tamper-proof casing, those kind of things, right? And evaluating that 5 steps where I analyze my architecture. I look into review my actual components of the system. I looked into what are the recommendations that GSM is providing me. Third part is like I'm reviewing my security model, and what are the risks that I can afford to implement to that part. Fourth part is about actual implementation of services. Based on all these combining these two things together, if I'm coming to some of the recommendations that I'll go for my development team is from the endpoint perspective. I'll say, okay, I want to have critical sections locked. I want my firmware to be locked. It may be secure. Also to maintain its identity, what we can do is you can have a unique encryption token for each endpoint. So whenever they're sending something, you have an encryption key, encryption token whenever they're advertising some kind of data. And if you're still going for some kind of higher kind of thing, you can have a tamper resistance cases, which is foolproof against a fault injection attacks kind of thing. So these are typical recommendations that you can have for this particular endpoint. Of course, depending on applications, they can still increase, and there will be certain changes possible, right? Looking from the security service perspective, right? So what we can do is, so we have an application server, we have a web server, right? So and everything we can do as a separate, and we create a firewall from that perspective, right? That is one thing that we can look for from this particular security assessment recommendation point of view. Another part we can look for, we have authentication part. Since I assume that when I'm encrypting something from the endpoint, I need an authentication from the service end, right? So I should have authentication and database tier to be added as a critical system. And I should have some analytical tool to verify whether my device has been compromised or not, right? So on this particular thing, these are the typical security recommendations that are possible based on this GSMA assessment point of view, right? So this is my consideration for this particular thing, right? So now coming to, so these are my typical references I have used from IoT security, GSMA IoT security, right? So they have this typical documentation from the security service perspective and those things. And right, so this is all about the presentation. And we are since you are webinar participant, we are selling our exploit ticket, which consists of IoT security assessment devices, right? Right. So that is on a 10% discount. So you can use webinar at 10 discount if you're purchasing that particular thing, right? So that's it from my side. So now, if you have any questions, you can go ahead with that.
Yes, Yashodhan, we have some questions in the chat box. You can address those.
Presentations. Yeah. Just a moment, I'm reading the questions. I'll come. Yeah, so the first question I'll address from the PSA perspective, PSA certified perspective. So what happens is PSA is something very specified to ARM architecture, like platform security architecture. They deal only with the ARM architecture, and they follow the what you call as the CC common criteria, and that is the reason they are not following into the compliance agencies, because they are not addressing the complete stack issue. They are addressing more kind of the issues with respect to ARM from the device perspective, or from the root of trust perspective, or from the manufacturer perspective, right? So that's why they are not considered for the compliance agencies part, right? That is one question. Another question is, as a part of industrial IoT ISN SCADA, if you can refer to what are the standards followed and architecture. Yes, for the IoT ICS and everything, we have a IEC 62443. That is, yeah, that is something, yeah, that is one thing that we have. Yeah. And IoT being like here, IoT is not referred differently. For the connected device, they are referred over here. I hope that answers. Any other questions?
I think we don't have any other questions. Yeah, we have questions.
See, IEC 62443, when you come to the drawback of IEC 62443, it is for ICS and SCADA, right? So here the security compliance things are totally addressed in a different fashion. So there is nothing like advantages or disadvantages. Like so they're dealing with a complete different kind of way for the industrial purpose. So these compliances, you cannot directly compare with IEC 62443. They're addressing some different aspects.
Please ask if you have any question on the chat box. So you should can resolve. Okay, so I think we don't have any other questions. So we can go ahead with the last part of the webinar. Yeah.
Okay.
So thanks, Yashodhan, for delivering such a wonderful webinar.
Thank you, everyone.
You have, if you have any other question, you can reach out to Yashodhan on mail. Thanks all the participants for being so attentive. We will share the webinar recording on LinkedIn page, so make sure you follow us on LinkedIn. Thank you.